Okay, everybody, here we are at the short answer questions for our Chapter 3 test, and here is where we are going to ask you to apply all of your vast knowledge of conversions, of density equations.
Some of them only have half vast knowledge.
Well, let's hope that they can gather some vast knowledge for this one. So looking at our first short answer, out of the, 7 that you need to work on.
Yes.
So question number 26, or hint 26, convert a metric measurement to another unit using factor label. Actually 27 and 26, 27
Yep. 26
are the
and
same.
27.
So go back over here. For every what, there's a what. That's a conversion factor. We want to see something in parentheses like that.
I want to see you cancel out your units.
Right.
Units on numbers.
What you have versus what you want. What you have to cancel goes on the bottom of the conversion factor. What you're trying to turn it into goes on the top. We will have given you multiple chances to practice and apply this, but this is what we want to see. Go back again, like we said, and watch that other video.
Watch the video with the funky beat.
Mr. Schwartzbeck, or whoever he is, I think is his name, and explains to you very easily how to do all this. So you have a couple like that. And number 28, you are asked to calculate the volume when you are given the density and the mass, and we want you to use factor label method.
Wait a minute.
Yeah.
Calculate the
Volume.
Oh, you're going to have to manipulate equations. This is more of a math question than a chemistry question.
Oh, no. Math is our way to explain what is going on with the chemistry.
Oh, okay.
So it's not just D equals M over V. You're going to have to switch that around. And you know algebra. You're in algebra 2 or higher. That's you're prepared for this. Okay. So 29. Calculate the density and then percent error. So this is a can you do a density problem, and can you identify how far off that is, how inaccurate or accurate is that. So we did this in the accuracy and precision lab. We'll be asking you about a metal. You worked with the metal aluminum and you made some measurements and you calculated its density, and then you looked up the real value, which we'll give you in this problem, and then you use that for the percent error equation. So make sure you know that percent error equation. We are not giving you equations on the test. Percent error is something you're going to use all year long.
All the time.
So you got to get that one into your brain. But it is a 2-part problem, so make sure you do both parts.
And then 30 is very similar, where we're giving you some measurements, and ask you to make this final calculation looking for, what are they looking for here? The mass.
The mass.
So we've given you some measurements. We want to see your work. Please do not just write down a number.
Right. And don't write down, or don't tell us later, I did it in my calculator. Okay, so you did the actual math computation in your calculator, but we expect you to write down everything you did to get to that point.
Right.
That's what we asked for in Oceans 11, that was what we asked for in labs. You should be ready to do that.
Show us what you're doing.
Every step, and your units in every step.
Ms. Rashar, why are significant figures necessary?
Ooh, significant figures. You need to explain why they're necessary, because you are only as accurate and precise as the tools you use.
So if I measured something with this ruler, and then with this ruler, one of those would be better than the other, right?
Definitely.
I would probably just be doing an estimate with this one.
Yeah.
And the best thing I could get was my estimated digit.
Yes.
But with this one,
It's not
with all those other markings on it,
Yeah.
well, the more precise the markings are, the more markings, graduations that are available, the more precise we can be with our significant figures. Okay, but why do we have to have them? Like, why can't I just put down whatever the calculator says?
Well, because calculators lie. Calculators are doing math. Calculators are not doing science. Calculators lie, and they will tell you every mathematically correct digit without any thought of the quality of work the measurer has done.
So that goes back to what we were talking about earlier, about how we round off numbers and how do we know how to round off numbers. We have to base that on the measuring device we have, and we can't go to 5 decimal places with a ruler like this. We have to cut that off at probably about 2. Okay, 32. Love this question. It's the last one.
Read it.
They get to draw.
I'm putting my foot down, and I am not going to tell them what we're asking them in any greater detail that is on the test hit sheet. Read the question. Read every word of the question.
Read it twice. Or 3
Especially the
times.
ones that are bold printed. And
Read
underlined.
the words. This is a great question. It's a nice sized point value question. It's a shame that students get this wrong, and they get it wrong because they don't read the question.
It has to do something like density.
It's density. Just trust me. Read the question. So here, during one of our breaks, we reset the mousetrap, the sorter of these ball bearings, and this wasn't our design. I figured out what was wrong with it, and here we go. So it's triggered. This release valve is triggered by a mousetrap.
So much for fixing the design.
And there we go.
And it sorts most of the balls. Yeah, it's actually pretty cool.
Yeah.
Look up science fair, listen to your teachers, get a partner, get a group, and check out science fair. The links are online, and we'll link them to Moodle. Ask about science fair.
Pick up an application or a
Registration.
entry form.
An
There you
entry
go.
form, right.
Thanks for watching.